Often, people with mental health issues will have lowered cognitive abilities, and as a result, lowered spatial awareness. Using the HoloLens, we've created a holographic environment which contains various visual cues and selected objective points. The user must make their way to the objectives, relying on the visual cues as a way of figuring out where they are. By having a patient walk through this environment a number of times, healthcare professionals are able to determine more accurately how good a patient's spatial awareness is. The application is based on the Morris Water navigation task, a task used for assessing spatial memory in rodents, specifically testing how well they can remember spatial locations of objects in the short term. It works on the idea of the rodent repeatedly seeking an exit from a circular pool of water, where over time the duration spent in water drastically reduces. The application includes a menu option when first launched, allowing therapists to set up the session beforehand. The therapist can enter the room size, selecting from a range of options. They can then choose a delay duration in seconds, which is the time a patient has to assimilate their surroundings. Finally, they are able to enter a patient ID through a number keypad, so that the trial data can be matched back to the correct patient. When the patient starts the application, an arena containing the spawn point is created. The user must make their way to the spawn point, indicated by a blue square on the floor. Once there, the square changes color to signify their arrival. Once they have arrived, the objective point will spawn, this time indicated by a green square. The user must make their way towards this location, remembering the steps they took to get there. Once they arrive, the patient will have a couple of seconds to assimilate their surroundings, making sure they know where they are relative to the visual cues. A blue square will then show up for a second time, indicating a second spawn point. Once the user makes their way to this spawn point, the final phase of the trial will start. The user must make their way to a retrieval point, where they think the green objective previously was. The user signifies their arrival at this point through either an air tap or the use of a Bluetooth clicker. This user interaction is indicated by an audio cue played through the HoloLens. Once they signify this, the application ends and all collected data is written to an output file. For each trial, an output file is created. The output file shows a record of the patient ID, statistics for both Phase 1 and Phase 3, such as the distance between objective and spawn points, and data about the paths that users took throughout the whole trial. The path data is presented as a series of coordinates, which the therapist can then map out and use for further analysis. Given the complexity of the problem and the use of new technologies, the outcome of this project is definitely a success. The team was able to deliver a fully functioning minimal viable product, which Mindwave Ventures can now test and further develop. Whilst the application is functional, its usefulness for healthcare professionals still needs to be found. By using this application in conjunction with the existing methods of spatial awareness analysis, therapists will be able to determine exactly how accurate the collected data is.